With this inequality, it's basically saying that we've got a parabola, and we want to know where is the parabola bigger than or equal to 0, or where is the parabola above the x-axis. Before doing the math, I want to just take a look at the graph so I've got an idea as to what's going on. X squared plus 3x minus 8 is going to be the parabola, and I'll just go to zoom standard. Here's the parabola, and so it is positive, or bigger than or equal to 0, I should say, in this area right here. So that's starting at about x equals 2, as well as over here on the left hand side, which is negative 1, 2, 3, 4, approximately x equals negative 4. Now I need to do some work. So begin by finding those x-intercepts. So take the inequality and change it to an equation, and then use either the quadratic formula or factoring. I believe that I'll try the quadratic formula. Never fails. X is equal to negative b plus or minus the square root of b squared minus 4 times the a times c. It's all divided by 2 times the a. So we've got a negative 3 plus or minus the square root of, well, this is 9, and this is going to be a positive 32. So we've got 9 plus 32. And then find the decimal answers. So we're going to have negative 3 plus or minus the square root of 41 divided by 2. Actually, one thing that I can do is go back to the graph and I can check to see if I got the x-intercepts right, as well as get the decimal answer all at the same time. Just go to trace and type in the x value. Parentheses, a negative 3 plus the square root of 41. There's the numerator, and then divided by 2. And it says that x is equal to a 1.702. So one answer is that x is equal to 1.702. Likewise, the other one would be negative 3 minus the square root of 41, which is divided by 2. That should be this one over here. Very good. So x is equal to a negative 4.702. Okay, now we need to put these on a number line. So now I'm going to verify what I believe I saw on the graphing calculator. And that is, over here there was an x-intercept of negative 4.702. And somewhere to the right over here, a 1.702. And now we need to verify that this side and this side will satisfy this inequality, that the parabola is bigger than or equal to 0. So what we need to do is, for each interval, pick a number and test it in this original equation. So over here to the left of negative 4, I could use a negative 5. So x equals a negative 5 is what I'm going to test, and use the original inequality. So we've got negative 5 squared plus 3 times a negative 5 minus 8. Is that bigger than or equal to 0? That's going to be a 25 minus 15 minus 8, is that bigger than or equal to 0? Well, this is 23, so we've got 25 minus 23, so a 2. Is it bigger than or equal to 0? And the answer is yes, that works. So that means that this side does make the inequality true. We should use that. And now if we test something in the middle like x equals 0, we would have 0 squared plus 3 times 0 minus 8. Is that bigger than or equal to 0? Well, what's left behind is just a negative 8. Is that bigger than or equal to 0? No. So we don't use the middle part. And likewise, pick something over here like x equals 2. And we would have 2 squared plus 3 times 2 minus 8. Is that bigger than or equal to 0? So a 4 and a 6 and a negative 8. Well, that leaves behind a 10 minus 8, or 2. And again, that's true, so all the numbers over here will make the inequality true. Now there's only one last detail, and that is we should write our answer in interval notation. So this interval over here, I use a square bracket because this has a bigger than or equal. If it only had the bigger than, I would use a round parenthesis. So in other words, do include the 1.702 and then go to the right forever to infinity. On the left hand side, it's going to start from negative infinity and go up to negative 4.702 and include it. And finally, union the two of those. And there it is in interval notation.